This demonstration will show the RESNET 1-point airtightness test form for data entry, which is part of the RESNET 1-point airtightness test quick guide. And I created a spreadsheet version of this test form for the demonstration today so we can show entering data into the form. And we're using the DG700 simulator that's hooked up to a real-time gauge and is used for demonstration purposes. So the first step is to turn it on, and then I'll connect the hoses here. Green hose going to the outside reference, and we can connect a red hose up here for our data input for our blower. We're not going to be doing a blower test, or just we could demonstrate taking baseline pressures for this demonstration. First step is we'll want to do a 10-second average for our 5 baseline readings. We're going to gather time averaging. The default is 1 second. If we click once, it'll go to 5 seconds. Click a second time, it'll go to 10 seconds. So now we're set at 10-second averages. Every 10 seconds, it'll flash with a new number, and we'll enter that number onto our spreadsheet here. Looks like we got negative 1.0. It's a pretty calm day today, and we don't have a lot of temperature difference between inside and outside, so our numbers will be pretty small. Negative 0.9. Negative 1.2 for a third number. And don't mistaken the auto zero clicking of the gauge for a new number. Look for it to flash with a new number. Negative 1.5. And our fifth number coming up here, negative 1.2. Okay, so I'll take my gauge off. So we've gathered the data we need there. We've got 10-second marked in our time averaging period, and then we'll write down our largest baseline reading, which is the baseline reading closest to 0, which in this case looks like it's 0.9. And we'll need to make sure and put our signs. Sometimes we'll have positive and negative numbers, and that will definitely make a difference. So we'll want to always put the sign on there. And then our smallest reading is down at negative 1.5. And it calculated the baseline range, the difference between that highest and lowest number at 0.6. And that's well within our standard level of accuracy of 5 Pascal. So as long as this number is less than 5, we've got a standard level of accuracy. Above that, 5 to 10, we have reduced invalid tests. We can't do the test if we have it more than 10. If we do have a number greater than 5, we can extend the time averaging period to say 30 seconds and take the numbers again, and that'll tend to tighten the range up. Or we can do a RESNET multi-point test or RESNET repeated single-point test. The next section, down to section B, is entering our blower information. And the path we choose here will depend on if we're using software, and we're going to enter this data into software, or if we're not using software, we're going to use charts to do the adjustments for temperature and elevation. We'll do the blower test different depending on what we're doing, because if we're doing a manual entry into software, the baseline readings we enter in will be used as the baseline readings. So in this case, we'll enter in negative 50, and our nominal flow we'll say it's 2000, and we'll hit ring A here. And we do actually we want to change our reading by 50 pascals, and the baselines we entered in are somewhere between between 0.9 and negative 1.5. So let's use a number partially in between there, and figure we'll want to change, instead of changing the we want to change the house by 50 instead of just bringing it up to 50. So let's go 51.2, say, is marginally between those. So let's bring the house up to negative 51.2. Then we're changing the house by 50. And if we're not using software, we'll be using the baseline function of the gauge, and we'll be using the CFM at 50 mode. So we'll enter a negative 50 here, and 2000 for our flow, and ring A. So gather the information a little bit differently depending on if we're going to be using software or not using software. Indoor temperature down in section C here, 70. Our outdoor temperature, 50. And our site elevation here in Minneapolis is about 830. RESNET requires you to do a temperature correction if the temperature difference between inside and outside is more than 30 degrees. So this isn't, but we're gonna still show it just to show the temperature adjustment. And if the site elevation is less than 5,000 feet, then you're not required to enter the site elevation. And the site elevation numbers you enter in need to be within 2,000 feet, and the temperature numbers you enter in need to be within 10 degrees. So they're trying to make it easy for you, and not trying not to make this process too complicated. But especially in temperature extremes, it does become important to and higher elevations, it can make a significant difference on your blow order number, so they want you to make those corrections. So we entered in a Model 3 for our blower door, and DG700 for our gauge, and RESNET. The RESNET standard also asks you to include your serial numbers, so you can include the serial numbers for your fan and your serial numbers for your DG700 gauge. And then the next page, page 2. So now it's carried in that CFM flow over. It's done our altitude correction based on our 830. It took that 830 times this correction factor of 1 plus 0.000006 times the altitude in feet, and it came up with that correction number. And now we'll use the temperature correction table that we have below here to make our temperature correction. And it's got a chart for pressurization, a chart for depressurization, inside temperature across the top, outside temperature down the side. So outside temperature, we're down to 50. We're going to follow that across to 70, and we're at 0.968 for our temperature correction. So we'll put that number in here. 0.968. And then it'll calculate our corrected CFM of flow at 1945, and if we had a reduced level of accuracy, where our baseline was between 5 and 10, we'd have to multiply that number by 1.1, and we would come up with 2140. So that's using the RESNET 1-point airtightness test form, which is part of the RESNET 1-point airtightness quick guide. To either use the data to enter it into software, or to use the formula and charts to do the calculation manually. The advantage of using the software is it will also print out a nice report.